Hello, colleagues and our dear students. You are welcome once again to Grandelve Tutorials. Today, we have a question posted to us by one of our colleagues for discussion. If this is the first time you have been introduced to this page, then be informed that Grandelve Tutorials page is where we discuss college and senior high school mathematics questions and concepts in details. Today, the question posted to us is solve 2 log square root of x squared plus 1 plus x base 2 plus square root of 3 plus log square root of x squared plus 1 minus s base 2 minus square root of 3 equal to 3. If you see the question, you see that the question is a full question, a full one question, and the question contains idea on logarithms, idea on sets, and idea on equations. Okay, so it's like 3 topics all embodied in one. This means that if you want to follow us in solving this question, you must have or revise your notes on logarithms, sets, and equations. The question has a challenge that we need to be aware of. First, the whole question seems to be insurmountable for the fact that the bases for the logarithms are different. Look at the first base. It is 2 plus square root of 3. The second base is 2 minus square root of 3. They are almost the same, but the arithmetic operation for the first one is plus, and the arithmetic operation for the second one is minus. This makes it a bit difficult to deal with. So it's a way of trying to see where we can make them to be the same in order that we apply the log rule. Okay, now let's look at considering 2 plus square root of 3. All right, let's consider the first base, that's 2 plus square root of 3. If we consider 2 plus square root of 3, which is the first log base, we need to consider it in such a way that we will rewrite it in a form that will help us to arrive at a situation where the result will be almost the same as the second one. That's the second base here. So let's try to write 2 plus square root of 3 in the form a over b. If you can write 2 plus square root of 3 in the form a over b, we will need its conjugate. Your idea on sets will tell you that the conjugate of 2 plus square root of 3 is 2 minus square root of 3. And so to have it in the form a over b, it means that we need to multiply it and divide it by its conjugate. All right. Let's see a typical example of that. That would be our first step on that. Okay. Multiplying and dividing by the conjugate of 2 plus square root of 3 will help us to arrive at this, which is in the form of a over b as we intended. That's 1 over 2 minus square root of 3. And that is true. That is beautiful. Of course, this result is not the same as 2 minus square root of 3, but at least we can see that we have the operations between the expressions to be the same. So that is a way forward. Let's hold on to that. Then consider the log expressions. The log expressions, for the first one, we have square root of x squared plus 1 plus x. And the second one is square root of x squared plus 1 minus x. You see, they are also two not the same. And what makes them not to be the same? Of course, the first one has arithmetic operation plus, and the second one has arithmetic operation minus. Anyway, let's try doing this too. Let's try to convert this one to in the form a over b. and see if we can have our way with that. Okay. All right. So trying to rewrite first expression, which is square root of x squared plus 1 plus x, in the form a over b, it will mean that we will need its conjugate, and its conjugate will be square root of x squared plus 1 minus x. The moment we get that conjugate, we will multiply and divide by its conjugate. Okay. And that wouldn't be difficult for us to do because I believe you already have that knowledge in sets. After multiplying the square root of x squared plus 1 plus x by its conjugate and dividing by its conjugate, we believe in your mathematics skills that you arrive at this simple expression 1 over square root of x squared plus 1 now minus x, just like this one. The plus that we had to be the operator for the first expression appears to be minus, okay, just like it appeared to be minus in this case, though they are now in denominator stage or form. Now we have this and that. We have rewritten the first base in the form a over b. We have rewritten the second expression, log expression, in the form a over b. What's the way forward? What do we do? Okay. Now let's try and represent the denominator in the first expression, that is in the first base, by a letter, and let's represent the denominator in the second log expression resolved here by a letter. We can use m and n, a or b, but let's use p and q in this case and see what we will do. So let's represent p by 2 minus square root of 3 in the denominator and q by square root of s squared plus 1 minus s in the second denominator. Okay, let's do that and see. All right. So we have p representing 2 minus square root of 3, as you can see here, and we have q representing square root of s squared plus 1 minus x, as you can see here. That's beautiful, all right? So we can move on. If you do this representation, then you bear me out if we conclude on this fact. We can conclude on this conjecture that 2 plus square root of 3, which was in the first base of our log expression, is the same as 1 over 2 minus square root of 3, as we resulted at here. This is the same as this. And since we are saying that p should be equal to the denominator here, it will be okay to write it as 1 over p. And let's come to the log expression square root of x squared plus 1 plus x. That one too resulted to 1 over square root of x squared plus 1 minus x, as you can see here. All right. And we represented that expression square root of s squared plus 1 minus s by q. And so you trust me with that. Let's increase the text a little so that you can see it clearly. Okay. So we have this to be 1 over p, and now um, we have this to be 1 over q. Okay. Then it means that in the original equation, wherever we see 2 plus square root of 3, we can put 1 over p there. And where we see x squared plus 1 plus x, we can put 1 over q there. Likewise, where we see 2 minus square root of 3, we can put p there. And where we see square root of x squared plus 1 minus s, we can put q there. So let's do that substitution and see where we will arrive at. Okay. We are now coming to do the substitution. We put p, q, 1 over p, and 1 over q in the original equation. To help your understanding, let's quote the original equation here. So that you see what we are doing. All right, we have 2 log 2 plus square root of 3, and we are saying that 2 plus square root of 3 is 1 over p. So it's there. And square root of x squared plus 1 plus x. And now we arrived at square root of x squared plus 1 plus s to be 1 over q, which is like that. Plus log 2 minus square root of 3. And now we are saying that log 2 minus square root of 3 is p. And we have square root of x squared plus 1 minus s. And we say that that too should be q, as you can see here. And everything is equal to 3, equal to 3. Okay. Let's enlarge this a little to help you to see it clearly. All right. Okay. So let's take it to say 24. All right. So I believe you can see this correctly now. We now have 2 log 1 over p as a base of the log expression 1 over q plus log q base p equal to 3. Before we go on, I want you to know this, okay? Note this, that anytime that you have an expression like 2 log 1 over p as a base of the expression 1 over q, that expression can be written as 2 log q base p. Let me repeat this part again. I'm saying that anytime that you have 2 log 1 over q base 1 over p is the same as the expression 2 log q base p. Okay. All right. Don't worry if this one sounds a little weird to you, because in our next video tutorial, we will try to prove this to you. Why we say that 2 log 1 over q base 1 over p is the same as 2 log q base p. So make sure you subscribe to our YouTube channel, and you see this proof in our next video. Okay. All right. Now, in that case, it means that we can put this expression in place of that. All right. And so that's why we come to our next expression to be this 2 log q base p, that's that, plus this, that's log q base p equal to 3. Okay, let's enlarge that a little to help you to see what is going on here. We accept this. Okay, so with this 2 log q base p plus log q base p, now the bases are the same. It wouldn't be difficult for us to, operate using the product law of logarithm. You remember? But before we can do that, we need to look at the exponential law of logarithm on this part. So finding the exponential law of logarithm on this part, we will have log q squared base p, right here, before we use product law of logarithm to operate both log expressions and equate it to 3. Okay, with that said, you accept that you have this as our next expression. Let's increase the text a little. So we have log q squared base p plus log q base p equals to 3. In that case, you also to accept this as our next step, right? Are we on the same page? We have log q to power 3 base p now because we find product law of logarithm on these two log expressions and we equate it to 3. This is q to power 1. Okay, product of q squared and q to power 1 is q to power 3, all having the same base, equal to 3. Now we need to find antilog at the left hand side. Okay, log at both at the log at the left hand side, so that we will have it in an exponential form. Thus, we must convert the log expression to indices, and in doing that, we have p to power 3 equal to q to power 3. Okay, you will be happy to see this because this is easy to resolve. Since the exponents are the same, we conclude that the bases are also two equal. So we can accept our next step to be p equal to q, right? Good. But look, the original equation had nothing to do with p and q. We introduced p and q for easy manipulation of the figures and expressions. So let's go back at where we said p is equal to 2 minus square root of 3 and q is equal to square root of x squared plus 1 minus x. Let's go to that. Okay, which means that if p and q are equal in this case, it means these two expressions are also two equal. I believe you agree with that. Okay, in that case, you accept this statement to be true and correct. So this is where we try to solve this equation, okay, involving x, so that we can now find the value of x. Okay, looking at this, there are two ways. You can choose to find square root. You can choose to find a square at the left hand side and at the right hand side of the expressions. That will lead you to a huge complication, and I don't advise that. So you rather see to send the square root of 3, which is a set, to where we have the other square root, so that the simple expression x rather joins the 2 at the left hand side. So let's find additive inverse of square root of negative square root of 3, and we find the additive inverse of negative x. Okay, and in that case, I know you'll be on the same page if I write 2 plus x equal to square root of 3 plus square root of x squared plus 1. Now it will be okay to find a square at both sides of the equation. Okay, so let's find a square at both sides of the equation, and that will be 2 plus s all squared equal to square root of 3 plus square root of s squared plus 1 all squared. So we do expansion here, and for the expansion of this, I'll advise that if you find it difficult to understand that the expansion of 2 plus s all squared is the same as 4 plus 4s plus s squared, then you can choose to write this 2 plus x um, in repetitive sense, that's as two factors, and you expand. You then have 4 plus 4s plus s squared as your last expression. Okay? Or you can follow me as we try to expand with a quick mind. We had a square here, squaring the 2, the first expression, to give you 4. And you have the square, which is the 2, to multiply the 2, giving you 4, to multiply the s to give you 4x. And you have the square to square on the s to get s squared. That's easy way to go through that. This is equal to the expansion of this, and this one to the square on the square root of 3 to give us 3, and the 2 times the square root of 3 times this expression plus the square on the square root of s squared plus 1 to have s squared plus 1. This one too, if you have issue with that, we will advise that you write it as two repeating factors and you multiply them and you expand the brackets to arrive at this same expression. So this is what we have now. Okay, and it will be okay if you see 4 at the left hand side, and at the right hand side you see 3 plus 1 here, which is also 2 4. So 4 at the left, 4 at the right, that goes to 0. And we can see positive s squared here, and we see positive s squared here. And the s squared at the left, s squared at the right, that one too goes to 0. Leaving us with 4s at the left hand side and 2 into square root of 3 times square root of s squared plus 1 at the right hand side. That will be very beautiful. Let's write that so that you can see it clearly here. Yes, beautiful. That's it. Okay. Now, with this, you divide through by the 2 here. Okay. So that you have 2x to the left and square root of 3x squared plus 3. Why square root of 3x squared plus 3? Here you see you have square root of 3 and square root of s squared plus 1. They are all, the 3 and the s squared plus 1 are all under square root and they are being multiplied. So product of sets will accept that 3 multiplies the s squared and it multiplies the 1 to give us 3s squared plus 3. Okay, and we have the 2 still intact. So we divide through by the 2, and we will have 2x to be equal to square root of 3 squared plus 3. So on our next step, we square both sides, that's 2s and square root of 3 squared plus 3. And that will mean that the 2s gives us 4s squared, and square root of 3 squared plus 3 squared will give us 3 squared plus 3. That's as simple as that. Okay. In that sense, we have 4s squared equals to 3 squared plus 3, and you try to, let's say, group like terms. We have 4s squared and we have 3s squared, so that can be grouped at the left hand side, and we have the 3 as a constant to the right. And that will mean 4s squared minus 3s squared, and we get s squared equal to 3. Is that fine? Okay. If that's fine. Then you bear me out that you have x squared equal to 3 as our last but one statement. Now x squared equal to 3. So our final answer will be the positive and negative square roots at both sides, and that will mean that x will be equal to positive and negative square roots of 3, and that is cool to understand that that would be the let's say the result of this equation. That is positive square root of 3 is equal to s is the same as s equal to positive and negative 1.73205 and so on and so forth. You know that is a set, so we have you can easily correct it to any possible number of decimal places that you desire. This brings us to the end of the solution to the question given to us by our colleague. Thank you for your time. If you have any question, don't hesitate to inbox us, leave a comment, and we advise that you subscribe to this channel on YouTube and Facebook. We also to pledge to let you know that we will go ahead to um, prove this expression as we said earlier. Thank you and goodbye.